Mr. Guthrie again, and we are continuing to look at gas laws. And the next one we're going to look at is Gay-Lussac's law. This is my favorite one. You can see the equation there. P1 over T1 will equal P2 over T2. And the reason this is my favorite one is because this is kind of why, like, if you throw things in the fire, they explode. And what's not fun about explosions? Nothing, because everything is fun about explosions. Real quick, check this out. Yeah, I've got a lightsaber pointer now, so that should be fun. Anyway, let's go ahead and start solving the problems. Again, this is exactly the same problem we did in class. You should have notes on this already. All you have to do is just go take a look at those as we're going through this. If you get confused maybe on how to do your homework, you can maybe use those notes to better help you understand what's going on. So here's the question we did in class. A sample of gas is at 112 Kelvin and 1.045 atmospheres. What will the pressure be if the temperature increases to 304 Kelvin? Well, again, we use the equation that we need to use for this, but we first need to define what we have. So 112 Kelvin, so that would represent my T1. And it's already in Kelvin. Oh, remember, temperatures always need to be in Kelvin for this. Thankfully, this already is in Kelvin, so we don't have to worry about converting it to that. We have 1.045 atmospheres. We do recognize atmospheres as a pressure. ATM, there we go. Now, a change has occurred. What will the pressure be? So we don't know what P2 is. If the temperature increases, oops, let's go ahead and erase that. And start again. If the temperature increases to 304 K. So what we have going on here is that we have nothing but temperatures and pressures, meaning that our volume is going to be held constant, so we are using Gay-Lussac's law. Now, this again is directly proportional, so since our temperature has gone up, we will expect our final answer for our pressure to have gone up as well. So our P2 should be larger than our P1 as we're trying to kind of think all of these things through. So with that being the case, let's go ahead and use these numbers to solve this problem. So there's our equation for Gay-Lussac's law. P1 over T1 equals P2 over T2. And so we defined what these things are going to be in the last slide. So we know that our P1 was 1.045 atmospheres. We knew that our T1 was 112 Kelvin. We don't know our P2. We will be solving for that. And we do know that our second temperature is 304 Kelvin. Now, my recommendation always is when you get to a stage like this, go ahead and just cross-multiply to begin solving for our P2. This is just a solve for X situation like in algebra. However, you can do this and get this in other different methods. I'll let you kind of choose how you would like to do that. But I always recommend cross-multiplying because, again, these numbers or these questions can be a little tricky, and this kind of helps to alleviate that trickiness. So in cross-multiplying, we will take the 1.045 atmospheres and cross-multiply it with the 304 Kelvin. So let's go ahead and cross-multiply that then. So 1.045 atmospheres times 304 Kelvin gives us 300, I'll write this over here, 17.68. And we got to remember our units, so atmospheres times kelvins as well. Atmospheres times Kelvin. Now we need to cross-multiply the other way. P2 times 112K. Well, that's simply just P2 times 112K. Alright, now we need to solve for what that final pressure is. So we need to get rid of that 112K, and we will go ahead and divide it so that it will cancel out. And in algebra, what you do on one side, you do on the other. Now I can see that my 112K on the right has completely canceled out, leaving me with just P2. I can also see that my units on the left side have a little canceling out. The kelvins go away, leaving me with just atmospheres. And now I just need to do the math. 317.68 divided by 112 to get my final answer, which is 2.84. And that would be my final answer. And again, that makes sense. Remember, this is a situation where pressure and Kelvin temperature are directly proportional. And as a result, since our pressure had increased, we had expected our pressure to increase, and indeed it did. Our initial pressure was 1.045 atmospheres, and now it is 2.84 atmospheres. It has increased as well. And there you have it. Again, as always, if you have any questions, leave comments, send me emails, get a hold of me. I'll get back with you as soon as I can.